In the last video lecture, we introduced the first two rules that uses quantifiers in first order logic for doing proofs. We did universal elimination and we did existential introduction. There's two more rules left. There is existential elimination, which is one that we're going to do in this video. And then there's also going to be universal introduction, which we'll do in the next video. So let's do existential elimination. If you remember the argument that we looked at in the past video, we noticed that the following was valid. The first premise here says that everything that's a cube is large. The second premise says everything that's large is to the left of B. And then we said that D is a cube. And from these three assumptions, we were able to demonstrate that there exists something that is large and that is left of B. Now, if we modify this argument just a little bit, you should notice, or you might notice that instead of just claiming that D is a cube, the argument should still work, even if we just made the claim that there exists a cube. So now I've replaced 3 with claims specifically about D with simply the claim that there exists a cube. The argument will work exactly the same in that it's still valid, right? Since there is a cube, then that cube by 1 has to be large, by 2 it has to be left of B. So how do we do these types of proofs? They're going to be a little bit trickier. They are in a certain sense kind of like disjunction elimination. So the trick here is to use a temporary name, right? So instead of saying that there exists some cube, we're going to say, okay, let's give the cube a temporary name, and we're going to discharge that a little bit later on. So if we do this in Fitch, we're actually going to end up needing to use a subproof. And so I think it's most easily demonstrated using Fitch. So let me open that in a moment. Okay, so I've got Fitch open here, and you'll see that I have the same premises as before. So for existential elimination, we need to give a temporary name to this claim that X is a cube, right? Before we had the claim that it was specifically D. But we're not given that information in these 3 premises. We don't know which object is particularly a cube. So what we're going to do is give that object a temporary name. Now, a really important condition is that that name isn't yet somewhere in use. So I can't, for example, say that B is the thing that's a cube, because I don't know if that B is the same as that one up here. And in fact, you might think, well, wait a minute, that would actually be a really weird consequence, because if I said that X, the thing that's a cube is also named B, then at some point I might be committed to the claim that B is left of B itself, and that's actually impossible. So we have to be careful to make sure that when we give this object that is a cube a temporary name, that we give it a name that isn't yet in use. So the way this is done in Fitch is we actually start a new subproof. And you'll see here, there's this little arrow that allows you to provide a temporary name. So let me call it C. And you'll see that it puts it in this box. So the fact that it's putting in this box is saying, hey, just for the time being, I'm going to use C as a temporary name. And then we can say, okay, let's just suppose that C, this arbitrary object that we've sort of picked, is a cube. Now we've got this subproof here. So now that we've got this, the proof will be actually really similar to the ones that, or the proof steps that we used before. So for example, I can say that using premise 1, that C is a cube, then large C. And here I'm going to be using the universal elimination rule like we did before. So that's line 1, and that should check out. I can also then say that C is large, right? Again, by citing 4 and 5 as the conditional elimination, or as we also called it, modus ponens, and that will also check out. I can then use 2 again to do the universal elimination. So I can say C large, then left of CB. And this here I would be citing line 2. Again, this would be universal elimination. Now notice I could have actually plugged in whatever letter I wanted. I could have, in principle, put in B or C or E. It doesn't really matter, right? When it comes to universal elimination, you can input whatever names you like, as long as the name that you pick replaces all the instances of X, right? All the instances of the variable that are bound by that outside quantifier. But here what I've done is I've intentionally picked C. I've done this sort of on purpose so that I can do this conditional elimination. If I had replaced the instances of X in 1 with another name, say E, right, then 5 would say if E is a cube, then E is large, but then I wouldn't be able to do modus ponens, right, because the antecedent wouldn't match what I have in number 4. Okay, so I've made sure to replace or done the universal eliminations using C specifically. So now that I've got 6 and 7, and right, the antecedent here in 7 is matched by number 6, I can then also say that C is left of B. And this will be, again, by the conditional elimination rule. Oh, and I need to cite those 2 lines. Here you can see why it's really important that in 4, we made sure to pick C, our arbitrary name, in such a way that it doesn't appear anywhere above, right? C hasn't appeared here. If we had made our arbitrary object B, then at this stage in 8, we would have the claim that B is left of B, which is impossible. So that's why we have that special restriction that when you pick a name, it has to not have appeared anywhere else. But when it comes to universal elimination, you are allowed to pick a name that does appear above hand. Okay, so now that we've got the claim that C is left of B, right? I'm in the scope of this subproof right here. Now what we're going to do is do the existential introduction. Right? So what I can do here is now say, actually, I'm going to be missing a step. I can take 6 and 8 and I can combine them together using conjunction. I can say large C and left of CB. And this is just going to be the conjunction rule, citing lines 6 and 8. And now that I've got that conjunction, right, just like we did in the last proof, I can then introduce the existential quantifier. So I can replace C with the variable X. So I want to do large X. And I'm going to replace the instance of C in this left of claim with X as well. I'm going to make sure I have that closing bracket again. And this is going to now be the existential introduction. So if I go under the introduction rule, I see the existential quantifier down there. I click on that. I need to cite number 9 above. It's just a little bit longer here. So you can see the whole thing. Now, from 9 to 10, right, that was existential introduction. And here's the bit of the sort of that can be tricky the first few times we do this. And this is the place where I said it's a little bit like the disjunction elimination, right? Or redoing the proof by cases. What I'm doing from the subproof out to line 11 is saying, hey, I had this name that I used just for the sake of argument. Right? What I'm doing is saying, look at number 3. Let me say that the thing that is a cube, let me just, for the sake of argument, call that C, and C isn't a name that I've used anywhere else beforehand. Look at all these things that I can derive from that assumption. Now what I'm doing in this last step is saying, well, look, I just picked an arbitrary name for 3, and that arbitrary name was C. Now I'm going to eliminate that assumption. So the rule I use is existential elimination. And what I'm doing is I need to cite 2 things. I need to cite 3, because 3 was the starting assumption, and then this whole subproof. And the reason why I'm studying this whole subproof is because I'm saying, look, what I've done is just given X an arbitrary name. I was able to derive this particular conclusion from that. And so now what I'm doing when I'm going from the subproof from 4 to 10 to 11 is I'm just discharging the assumption that the thing that is a cube was called C. And I can do that because the name I had used was arbitrary. I had just picked out an arbitrary name and said, okay, let's say that the thing that is a cube is called C. Done my derivations, and now I'm saying, okay, let's get rid of that initial assumption, and then I can justify that using the existential elimination. And you can see the format here, right? That when I put my mouse over the rule, you can see the format, right? I started with an existential claim. I made a temporary assumption that the thing that is S is called C. I've gotten some conclusion Q, and then I can discharge my assumption that the object had to be called or was temporarily called C to make that conclusion. That's what I've done here. So if I check that step, good. It's saying it's not even a sentence because I don't have my closing parenthesis. So that will check out. So what can be difficult here is seeing that, look, 10 and 11 actually have the same sentence. And that's just like in the proof by cases. In both of the subproofs that we had in proof by cases, the conclusions had to be the same in both those subproofs. And that's what allowed us to then pull those sentences, at the end of the subproofs out onto the main line. Okay, so that's an example of how to use existential elimination.